I'm going to just use the letter C. If I replace x with x minus c, that's going to move right c. And if I replace x with x plus c, that's going to move the graph left c. Okay. If I have the whole function, this is left and right. If I have the whole function f of x, and after the function I add c, that's going to move it up c. And if I have a whole function and after the function I subtract c, it's going to move it down c. Okay, so you're going to, we'll do some in a second. You're going to be sketching maybe some graphs today with things like that. Just sketches based on your knowledge of the basic functions, okay? Like if I wrote f of x equals the absolute value, I close the bracket plus 3, I think hopefully you could draw a V moved up 3 without looking at your calculator. Okay, so what about this? Sketch a graph of f of x equals parentheses x minus 2 cubed. Okay, so what function is that related to? Cubing function, right? X cubed, which looks like what? Can you sketch a picture in the air? Like this? This is the x cubed graph. What does this do? Careful, X is a liar. Moves it right too. And so all I mean is, can you just move those points over? Like this is the point 0, 0. Just move it over here. It used to go through 1 cubed, negative 1 cubed would so make it kind of go 1 up and down, and there you go. That's what I mean by a sketch. Okay. So that's translations or slides. Let's go on to reflections. Do you remember reflections? Okay, here we go. There's only 2 types that we're going to recognize: over the x-axis and the y-axis. When you're doing the x-axis, what happens is you take the function and you make the entire thing negative. You take every single sign there would be then and flip it around. If you're reflecting over the y-axis, what you do is you go actually into the function and replace every x with a negative x. Okay. And so let's say I had this point over here, AB. I hope this makes sense. To reflect it over the x-axis, wouldn't the x-coordinate stay the same? but the y coordinate would change to the opposite. So that's why the x stays the same, and I make y equals that opposite. And to flip over the y-axis, the x coordinate becomes the opposite. Okay, so my question is this. How is y equals the square root of negative x related to this then? This is a basic function. How is that related to that if what I told you was true? It should be a reflection over the y-axis because I actually went in and replaced x with negative x. Okay, so just so you believe me, oops. Hopefully that looks familiar to you, and then you can just see then there would be y equals negative x. So what would it look like then if it was reflected over the x-axis? The opposite sign is in front of the entire function, okay? Sorry, reflection over x-axis. There it is. Like what? You must have football on the brain. All right. So the last thing that we're going to talk about are vertical and horizontal shrinks and stretches. And gosh, I've given lots of notes over the years on these, and I'm going to put some notes down, but the best thing we can do is just look at some examples and look at what they do. Okay. Now remember what I said about x. What did I say about x? X is a what? A liar. And you have to remember any kind of transformations, whether they are slides or stretches related with x, they lie. So if you actually have x divided by something, you would think it would get smaller, right? But if you have x divided by something, it actually horizontally stretches it. Okay, when it's in front of the function with y, it's what you would think it would be. So I'm going to say then, when I have a function f of x, and in the function I do x divided by c, we're assuming c is a whole number, okay? Then what that does is actually is a horizontal stretch of c. If in a function we have c times x, that is actually a horizontal shrink of 1 divided by c. Again, we're assuming c is greater than 1 here, the whole number greater than 1. So these are the horizontal. Okay. And then for vertical, I'm going to just describe it this way. For a vertical stretch, what you're going to see is something out in front of the function. Okay. And whatever that number is, okay, if it is greater than 1, it is a vertical stretch. It's greater than 1, it's a vertical stretch. If it's between 0 and 1, it is a vertical shrink. I am taking out that, I don't know why I put that there, maybe because it's Monday, and it's only 8:25 in the morning. Why would c not equal 1? What would that do to a function? Nothing, yeah. So it shouldn't include that. And it shouldn't be 0 either. I'm crazy. Because 0 would make it go to 0. Okay. So going back to, can I flip this over? Are we good, or should we? Going back to our square root, okay. I'm trying to think of a good one that we would see it. Let's look at the square root. Ooh, no, I'm going to do this one. This is a good one. Absolute value. Okay, so if I wanted to do, let's pick 3. If I wanted to do a horizontal stretch of 3, according to what I just said, what should I write? X divided by 3. Okay. And now watch what happens. It's going to actually stretch it. Because X is a liar. Liar, liar, pants on fire. So there's my original. Did you see it stretched horizontally? Okay. Now, if I wanted to see what it did when I did 3 times x, let's do that. 3 times x, now it's going to be inside the original v. So there's the original v of the absolute value, and there is the shrink. So f of x equals, that's actually a horizontal shrink of, we'd write 1/3. You don't want to write horizontal shrink of 3 because that doesn't make any sense. Shrinking something would be multiplying it by 1/3. Multiplying by 3 wouldn't shrink something. This is weird though. A horizontal shrink kind of looks like what? A vertical stretch? Sometimes they're the same. Why would, in this case, this one I just did, a horizontal shrink of 1/3, doesn't it also kind of look like vertically stretched? Anybody know why? Think about this absolute value here. Couldn't I pull that 3 out to the front? And then it would be in front of the function in that case? Yeah. And so, in that one, if you think about that, I'm going to show you just, not with all of them, but with absolute value, for instance, if I put the X here and put the 3 out in front, there's not going to be a difference in those graphs. If you look, it never, you can see it just graphed right on top of the other one. Okay, so let's write this. If there was a 3 times absolute value of X, another way of looking at that is a vertical stretch of 3. When they're outside, they're like what you think they would be. If I pulled a 1/3 out to the front, that's like a vertical shrink of 1/3.